Hi, PreCalculus. Here is fall exam review C. I'll work on B tomorrow. See if I can't get through C before I go pick up Kate. All right, find the equation of a line that is parallel to this line and passes through the point -5, 3. So if I'm parallel to this line, I'm going to figure out what is the slope of this because a parallel line would have the same slope. So I'm actually going to, we've got 4x plus 5. I'm going to move y to the other side, but I'm going to put it up here because that's the way we like to see it. And remember, this is your slope. So the slope of this line is 4. It's got to go through this point here. So I'm going to use the point slope form to come up with an equation. So I got y minus 3 is equal to my slope, which is 4 times x minus a minus 5 would be plus 5. Now when I look at my answer choices, notice how all the numbers, everything is on one side instead equal to 0. So I'm going to multiply this out and then move them all over. So this would be y is minus 3 is equal to 4x. 4 times 5 is 20. And then I guess we'll go this way with the y. So I've got 4x minus y. And then plus 3 to the 20 would be plus 23. And we get D as our answer. For number 2, find the domain of this function. The domain is anywhere, any x that I can put into this function. The only x that I can't put into the function is whatever makes this denominator 0. So x plus 3 can't be 0, which means x can't be -3. So I want the one that goes from negative infinity to positive infinity and just misses this -3. That's the only one. It can be 1/2. Remember, your numerator can be 0 all day long. That would just be 0. It's when your denominator is 0 that we're worried about. All right, number 3. Which of the following functions are odd? So remember, in order for it to be an odd function, it's symmetrical about the origin. So for 1, I've got the graph y is equal to 3. This guy is symmetrical about the y-axis, but not about the origin. So it's not 1. Well, 1 is not odd. For 2, I've got x cubed plus 3. You can do this here. And again, notice it's not symmetrical about the origin. If we flipped it across, say, this line here, you wouldn't get a carbon copy on either side. And then for h of x being negative x, that would be this graph here. And if I flip it across the origin, notice you're flipping right on this line. So this line wouldn't change at all. So the answer is 3 only. All right. Say I don't understand the graphs and I want to figure it out algebraically. If it's odd, then we know f of negative x has to be equal to negative f of x. So in other words, if I plug in a negative x, it's going to spit out a negative y. So if I put in negative x in this function, there's nowhere to put it, so it's just going to be 3. This is not minus this guy, so this one's not odd. Looking at g of negative x, I put in the negative into the cube. That would give me a negative x cubed plus 3. So I did change the sign of the x, but not of the 3. So again, this one is neither even or odd. And then for h of x, we've got h of negative x. When I plug in negative x, negative minus a minus becomes positive. This is the opposite of this one, so that's why this is the only odd function. Number 4, find the value of f of 3 if this is our piecewise function. So first we've got to figure out where is 3 at in our domain. 3 is greater than 2, so f of 3, I'm going to plug 3 into this piece here. So 3 minus 5, which is -2. All right, number 5, f of x is x, and g of x is 1 over x. They want us to find f over g. So I'm going to put x divided by g of x, which is 1 over x. This is x over 1 divided by 1 over x. We're multiplying fractions, so we're going to we're dividing fractions. So we're going to multiply by the reciprocal. X times x is x squared over 1. So your answer would be B. right, which of the following numbers is not a potential rational root of f of x? All right, remember your potential roots are the factors of this guy over the factors of this guy. So plus or minus 1, plus or minus 2, all over 1, 2, 3, 6, 9, and 18. So it's either going to be 1 over 1, or 2 over 1, or 1 over 2, or 2 over 2, or 2 over 3. So if I look at these guys, do I have a 3 on the top and a 2 on the bottom? I don't. So this is the one that's not a potential. Notice I do have a 2/9. I do have a 2 over 1. I do have a 1 over 6, and a negative 1 over 2. Those are all represented there. For number 7, the graph of this quadratic function can be obtained by transforming it from the parent function, which is x squared. Which of the following transformations must be used? All right, it says we're going to go to the left 4, but that's horizontal. We're going to do the opposite of what it says. We're going to move 4 units to the right, and we're going to go up 5. So I want 5 units up. So I want the one that's got 5 and 2 in it, which would be A. The vertex of the parabola given by this equation. In order to find the vertex of a quadratic function, you got to put that quadratic function into vertex form. So we need to complete the square here. Sorry, it's spaced out. I want to separate these guys and kick negative 1 to the curve. Now, in order to complete the square, though, I'm going to take out that 3 because I can't have a leading coefficient, which means this guy in the middle is going to be 2 over 3. So we can check that. 3 times x is 3x squared. 3 times 2/3 is 2x, and then minus 1. Now I'm going to take this middle guy and divide it by 2, which means I'm going to multiply it by a half, by its reciprocal. And the 2's cancel, and so this is 1/3. And that's the guy I'm going to square to put here. So 1/3 squared would be 1/9. But keep in mind, we're not really adding 1/9 here. I'm adding 3 times 1/9, which 3 goes into here 3 times. So I'm really adding 1/3 here, which means I got to subtract 1/3 out here. All right, so this would be 3x plus 1/3 squared. And this is minus 3/3 minus 1/3, which is minus 4/3. So my vertex is opposite for the x, which is negative 1/3, and same for the y, which is negative 4/3. So we're looking at D. Let's do one more, and then we'll move on to the next video. All right, find the horizontal asymptote and the vertical asymptote. Your vertical asymptote is what makes your denominator 0. So what makes this guy 0? Unless you've got a hole, which we don't have a hole for this one. So for this one, 2 is equal to 3x divided by 3. My vertical asymptote is at x equals 2/3. So I know automatically it's not going to be B, and it's not going to be C. It might be A, D, or E. My horizontal asymptote, that's where you look at the degree of your numerator and the degree of your denominator. In this case, they're both the same. And when the degree of the numerator is the same as the degree of the denominator, y is equal to the leading coefficient of the numerator divided by the leading coefficient of the denominator, which would be negative 1. So y equals negative 1 would be my horizontal asymptote. All right, that's 1 through 10 coming back. Next video, we'll start up with number 11.